We've been having so much fun. Get ready to double that fun with double angle identities. Double angle identities are just the trig function twice of an angle, right? Sine 2a, cosine 2a, tangent 2a. You can read the identities that follow. Let's see how these can be applied. If sine theta equals negative 7 over 25 on the interval pi to 3 pi over 2, we want to find sine 2 theta, cosine 2 theta, and tangent 2 theta. First step, let's find which quadrant we're in. Alright, we've got a sine value of negative 7 over 25, so we know we need to be in the negative y-axis, but they also tell us the interval from pi to 3 pi over 2. Well, this axis is pi, this axis is 3 pi over 2, so we're going to be right here in quadrant 3. Let's go ahead and draw that triangle. That gives us an opposite side of negative 7 and a hypotenuse of 25. Doing Pythagorean theorem, we get an adjacent side of 24, but we're going to make it negative because we're on the negative x-axis. And of course, this is going to be our theta. Now, first things first, we want to find sine 2 theta. And the identity for sine 2 theta is 2 sine theta cosine theta. I just got that from our double angle identity for sine. Next up, all we need to do is find these values here, using the triangle that I drew on our coordinate plane. So, of course, we're going to still have our 2. Next, we want sine theta. Sine theta is going to be negative 7 over 25. So we can multiply that by negative 7 over 25. And next, we want cosine theta. Cosine theta is negative 24 over 25. So we can multiply that right here, negative 24 over 25. Then all you have to do from there, well, is simplify it. And that's going to equal 336 over 625. We could proceed to find cosine 2 theta and tangent theta. All we would be doing is plugging into these different identities. Notice, cosine 2a has 3 different options. Either one of these will give you the same answer. So it's up to you which ones you want to use. Let's try setting up another. If cosine theta equals 3/5 on the interval 0 to pi over 2, let's find all those double angles. Again, let's start by finding which quadrant our angle lies. Since we lie between 0 and pi over 2, I know that the triangle has to be in quadrant 1. My adjacent side is 3, my hypotenuse is 5, and if I do the Pythagorean theorem, I know I'm going to get opposite side of 4. This time, why don't we find cosine 2 theta instead of sine 2 theta? I went ahead and chose cosine 2 theta equals cosine squared theta minus sine theta. Again, these are just coming from my identities. I could have picked either one of these 3. I'm going with the cosine squared minus sine squared. Alright, from here, we just need to fill in these values using our triangle. Doing that, my cosine theta is going to be 3/5, so I have 3/5 squared since we're cosine squared. And my sine theta is going to be 4/5, and I do 4/5 squared because I have sine squared. If I simplify that out, I'm going to get 3/5 times 3/5. That's going to be 9/25 minus 4/5 squared. That's going to be 16/25, giving me a grand total and my final answer of negative 7/25. We've just done a couple examples here, but make sure on your homework that you are solving for all 3 of the double angle identities.